All right, please make sure that everybody has their notes open to this page here on permutations and combinations here. The first thing I'm going to need is 3 people. I'm going to ask 3 of my most serious classmates here to get up in front of the class here. So why don't we get the real serious ones? Adam, Jack, and Egan, why don't you come up and line yourselves up in front of the class, please. Come on, guys. Come on, get on up and line yourselves up in a row. In fact, why don't we start off with, in this row, we'll have Adam first, then Jack, then Egan, in that order. Okay. All right, so this is one way of arranging Adam, Jack, and Egan into one arrangement in front of the class. Let's say we switch just 2 of them. Let's leave Adam first. We'll switch Egan and Jack. This is a second arrangement. All right. Can you guys please move yourselves into another arrangement? In fact, I'm going to ask you to stop this video in a second, but I want you to arrange yourselves into as many different arrangements as you can and write them all down. Have the class write them down, record them while you guys are moving around. So I'm going to stop the video, and then once you guys have them all written down, we'll start up again. All right, so hopefully you were able to find that there were 6 ways of lining up the students, these 3 students. So thank you guys. You guys can go ahead and have a seat. So how many choices? When we lined up 3 students, we basically had a choice for one, a choice for the second position, and a choice for the third one. And this is the same strategy we've been doing it for these other probability problems here, finding the number of outcomes there could be. We say we have this many outcomes for the first position, this many outcomes for the second, this for the third. Then we use a fundamental counting principle to multiply them and find the answer. So how many different students do we have to choose from for this first spot? All right, 3. There were 3. We could have had Adam, could have had Jack, we could have had Egan. So those are 3 different spots, 3 different choices. All right, but now we've used one of them up. We've used one of those students in that first position. How many do we have left now for that second position? How many students do we have to choose from? All right, we've got 2 students to choose from for that second spot. Okay. Now we've used up 2 of the students. How many students do we have to choose from for that last position? Well, there were 3. We've used up 2 of them. There's only 1 left. And so this answers we had 3 to choose for the first spot. We had 2 to choose from for the second spot. And for the third spot, we have 1. So using the fundamental counting principle, we have 3 times 2 times 1. And we get there were a total of 6 ways of organizing these 3 students in a line. Okay. So this answers the next question. Using the fundamental counting principle, how many ways? Oh, sorry, this is a slightly different one. Using the fundamental counting principle, how many ways are there of arranging 6 students in a line? Well, we just did it for 3 students in a line. Can you find it for 6 students? See if you can find the answer. We'll stop this and then have you check to see if you've gotten it right. All right, so hopefully you were able to find that there were 6 times 5 times there were 6 people to choose from for that first spot. Then we've used up 1. There were 5 for the second spot, 4, 3, 2, 1 as we go down, which means there are 720 ways of arranging 6 students in a line. Should we go ahead and try to do that? We get 6 student volunteers? Nah, that's going to take too long. I don't want us to find all 720 ways of doing that, so much easier with a smaller problem. But this fundamental counting principle is nice that it works for these much longer ones that would take a long time for us to do this and actually find all of them. All right. So another way of writing the 6 times 5 times 4 times 3 times 2 times 1 is this way. 6 with an exclamation mark. That means I must have to say it like 6! Actually, that's not true. That would be sort of an English way. In math, that exclamation mark does not mean excitement at all. It means factorial. So that when you see an exclamation mark, don't think that this is the number 6 being very excited here. It's not. It is simply 6 factorial. That's how we say that. And what it means is 6 times 5 times 4 times 3 times 2 times 1. In other words, 6 factorial means 6 times every integer below it, 5 times 4 times 3 times 2 times 1, all the way down to 1. And the reason why we have a special name for that is actually when we're counting things and trying to find outcomes, this principle comes up quite a bit. All right, so if we know how to write this 6 times 5 times 4 times 3 times 2 times 1 as 6 factorial, how would you write 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1? Go ahead and write the answer. How do you say that? Well, it's 8 factorial. Can everybody say that out loud? 8 factorial. Okay. Just get a little practice saying it. All right. Can you guys go ahead, if 8 factorial is 8 times 7 times 6 times 5, can you guys go ahead and find 3 factorial using your calculator? I'm not going to tell you what that is. We'll check in a minute. And do number 9 as well, 8 factorial. Okay, hopefully you were able to find that 3 factorial is 3 times 2 times 1, which is 6, and 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You can see why we don't like saying that. We just say 8 factorial. It comes out to 40,320. All right, so we're going to use the same principle for arranging letters in a word. So I'm going to use one of the best words that's out there, the word Seth, or the name Seth. And we're going to figure out how many different ways there are of arranging those 4 letters. So again, there's 4 letters. So I'm going to have 4 of these spaces. So I've got 4 choices to make. For the first choice of letter, how many letters do I have to choose from? I hope you're able to see with 4, there was an S, there's an E, a T, and an H. There are 4 letters to choose from. Now, I've chosen one of those letters. How many letters now do I have to choose for the next spot? All right, hopefully you've gotten there's 3. All right, and then we've used up 3. We have to use up this one. We've used up 2 letters now. How many do I have for the next spot? I have 2, and now I've used up 3 of the 4 letters. I only have 1 letter left that I can use. So using the fundamental counting principle, I do 4 times 3 times 2 times 1, and I throw that into my calculator, and I get 24. Shouldn't even need a calculator for that. 4 times 3 is 12, times 2 is 24. Okay. Can you guys please go ahead and do number 11? Try the same thing with Carlos. How many ways are there of arranging the letters in the word Carlos? When you're finished, we'll stop it now, and please check when you're done. All right, so keep in mind here, hopefully you got 720 ways. Don't forget to write your units in there. I forgot to do that number 10, and I fixed that. There are 24 ways of arranging the letters in the word Seth. There are 720 ways of arranging the letters in the word Carlos. Okay. Okay, here's where it starts to get a little bit more difficult for number 12 here. There are 6 letters in the word cheese, so we would think if they were all different letters, the answer would simply be 6 factorial. 6 times 5 times 4 times 3 times 2 times 1, which is 720. Okay, this is only if all the letters were different. But we actually, in this particular case, we have 3 letters that are actually the same. There's an E, an E, and an E. Well, we can do this by looking at, I'm just going to look at one way of organizing this word, and let's say it was E, let's say C, S, E, H, E. All right, that's one way of organizing those 6 letters. Let's start off treating as though these E's, I'm going to rewrite it again here. Let's pretend that the E's were different letters. So instead of calling them, making up different letters from, I'll call this one E1, E2, and E3. All right. Another way of organizing this very same word here is I'm going to do the exact same thing with the E's, but this time I'll keep this one as E1 and I'll switch the 3 and the 2. Here, that's a different way of organizing those letters if we're treating the E's differently. Okay, let's see how many of these different ones we can get. All right, so now I'll try E2 as my first one, E1, and E3. Now keep E2 again as the first one, but this time we'll switch these two, E3 and E1. Oops. Okay, there are, I'm going to draw a line here because that one wasn't one. So there's 1, 2, 3, 4 so far. Now I'm going to try E3 first. We've got C, S, E1, E2, and one more way of organizing with the E's of this same combination of letters here in the same order with just moving the E's around. All right, so this is E2, H, E, 1. Okay, so for this particular, all right, so stick with me for just a minute here. This is the really complicated part to try to understand how this all works. The math is not going to be that hard once we figure out a system of making it work, but understanding why it works here's where it's a little bit challenging. So we have 6 different ways of writing this, basically these 6 letters organized here. If you notice, like these 6 different ones, in reality, they're all the same because the E's are not different. They're actually all the same. But there are 720 ways of arranging 6 letters. But actually, these 6 arrangements here are the same, really, as this one because the E's are not different as like these arrangements are. So really, for each arrangement that we have that looks like this, there are 6 of these. So in other words, we actually need to take this number and divide it by each of these 6 arrangements to be able to come up with just this one. So really, all 6 of these arrangements are really one. So we need to take the answer 720 and divide it by 6. All right. So the question is, so this is really 720 divided by 6. But where does this 6 come from? So we know that the top of this is going to be 6 factorial. We have 6 letters being arranged in a row. That gives us the 720. But where does this 6 come from? Well, there really are 3 letters, the E1, E2, and E3. And there's one way of putting, there are 3 places to put the first one, 2 places to put for the second spot, and now we've used up the 2 letters. There's one more here. So it's really 3 factorial ways. That actually is where that 6 comes from. There are, for every one of these arrangements, where actually the E's are all the same, there are 6 different arrangements if we treated E as a separate letter. So actually, the formula for arranging this here is simply taking that same, we still use the 6 factorial, there's 720 ways, but we need to divide that by, in this case, there are 3 E's that are repeated. This is the important part here now. 3 E's so we actually are going to divide that by 3 factorial ways that these are repeated here. So we need to get rid of those. So then we're going to have 720 divided by 6. And that gives us 120 ways of arranging the word cheese. All right, so that probably sounded really complicated, but once we start seeing the pattern in these words, then it'll start making sense. All right, so if all the words, I think you guys should have now that if we have all the letters are different letters, we simply count them up, 1, 2, 3, 4, 5, 6, and we get 6 factorial, and that's going to give us a total number. What makes it difficult is when the letters are repeated. So on the next video, we'll use this next one as an example of how to continue this pattern.